Max, min. Most probably, we have to create a function and find its maximum or minimum. That's it. So I'm going to share my screen and go to optimization problems right here, 4.7. And we'll choose a couple, and then we'll look at Newton's method. Page 9. Okay. So allow me to choose. There are a lot of different situations, tons. I just want to start with something like 26. Find the point on the curve y equals the square root of x that is closest to 3, 0. And then I'll let you choose if you like. If not, I'll continue choosing. Okay. So what is this problem telling us, and what is it asking? So first of all, I'm going to graph this function. And we graph this function so many times, a million times, especially in our past experience. So the square root of 4, 2. Square root of 1, 1. So this is the graph of y equals the square root of x. And there is a point, 3, 0, which is this point. And they're asking us to determine the point on this graph that is the closest. When I say closest, I mean minimum distance. So the closest, I don't know, grocery store to my place means the closest, the minimum distance from my place to the grocery store or gas station or whatever you want. So this is a minimizing or an optimization type of problem. Now, I would picture a point somewhere. I don't care where. I don't even think. I picture a point. So let's say this is my point. And this is a point on the graph of the function. If the x-coordinate is x, can anyone give us the y-coordinate? So can anyone, maybe this is not a good color. So can anyone tell us the coordinates of this point if the x-coordinate is x?
So I'd find the y-coordinate?
Yes. How do I write the y-coordinate? The function is y equals the square root of x. Very good. That's it. X comma f of x. Perfect. Thank you. Now, I would like to determine this distance from a generic point P, anywhere you want it. You can picture it here. You can picture it here. It doesn't matter where you want. But now I would like to determine this distance. I'm not going to call it d because d is, for us, derivative. I'm going to call it w. So I have 2 points. Can anyone give us the distance formula? Anyone?
Isn't it y2 minus y1 over x2 minus x1?
Okay, x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. So I'm going to denote this by x2, y2, and this by x1, y1. x2 minus x1 squared plus y2 minus y1 squared is the distance between 2 points. I'm going to call this point Q. So the distance PQ is this. And no, you cannot simplify. The square root of a sum is not simplifiable. So then my W, which is a function, right? We'll see in a moment. X2, x minus 3 squared plus y2 square root of x minus 0 squared. So now I know when I simplify this, I get x squared minus 6x plus 9 and plus x, because the square root of x minus 0 is the square root of x, the square root of x squared is x. So now I know that I created a function. It's a function of one variable, x, that looks like this. X squared, combined like terms, minus 5x plus 9. I'm asked to find the minimum of this function. That's what it says. Find the point that is the closest on this graph, the closest to this point, right here. So, how do I determine, based on what we know from calculus, how do I determine a minimum of a function? That's all it boils down to. What do I need to determine?
The critical numbers.
Yes, so first find the derivative, right? I cannot find the critical numbers before finding the derivative. Very good. 1 over 2 the square root times
2x minus 5.
excellent. When I set this equal to 0, this cannot be 0. If this is 0, the distance is 0, and we have nothing to discuss. So when I set this equal to 0, what do I get? X equals, anyone?
Or 2.
Excellent. Thank you very much. So then, because I have 2x minus 5 equal to 0, I move 5 and divide by 2. Perfect. Excellent. Thank you. So now, I only need to write x from 0 to infinity. That's the domain. And 5 halves and 0, and study the sign. Do I have to study the sign of this piece? Yes? No?
No?
No, because this is always positive, of course. I only study the sign of this. To the left of 5 halves is negative, to the right of 5 halves is positive. So this is typical for a minimum. So I showed that this function has a minimum. Now, what is the point? So the point is x, comma, the square root of x. X is 5 halves, and this is the square root of 5 halves. So the point closest to 3 halves, P, is 5 halves, comma, the square root of 5 halves, is the closest on the graph on y equals the square of x to 3, comma, 0. Guaranteed. Now you can go back if you want and just put it where it should be. It just happens that it's somewhere here, of course, as expected. I don't care. I don't have to graph it. So 5 halves, comma, the square root of 5 halves is right here. And this is, as expected, the shortest distance. The point I was making by showing a point anywhere is that you have to start with a point that is a generic point. Anywhere. And this was very well done. I mean, here or here or here or here. It doesn't matter. The answer will give you the exact point so that the distance is the shortest. Good. With optimization problems, we can go on forever. So let's look at a couple. Oh, what's going on here? I'm logged out. Maybe I can get back in. Please. Ah. Thank you. Okay, so this was 26. So we know how to determine something like that with a point. Oh, let's see, maybe the poster problem. Let's look at the poster problem. Okay, 42. A poster is to have an area of 180 square inches. 180 square inches. With 1 inch margins at the bottom and sides. 1, 1, 1, and 2 margin at the top, 2 inches at the top. What dimensions will give the largest printed area? Okay. So we're asked to find the length and the width or height. We're going to denote them in a minute, such that this area is maximum. So here's the poster. There is a printed area in the middle and margins of 1 inch, 1 inch, 1 inch, but 2 at the top. And we want to determine, keeping in mind that this is a restriction. You can say, well, why don't you use the biggest possible you can? No. We already know that this entire area is 180. So we want to determine the length and the height of the poster so that the midpoint part of the printed area, in other words, is the maximum possible. Keeping in mind that we are restricted by 180 square inches. So we basically have here two variables, the length and the height. And based on that, we maximize this area. But in order to maximize an area, I have to have a function. If I don't determine for this a function, I don't know how to find the maximum. If I have a function, I will use calculus to find the maximum. Finding the maximum will give me the exact length and height. Okay. So first of all, we have to denote the length. Let's say I'm going to denote it by x, and the height, I'm going to denote it by y. Is there an equation that I can already write, knowing that the length is x and the height is y? Can I write something?
A equals x times y.
Very good, of course. This is extremely important. And now let's try to make up a function that represents this area. I'm not going to call it A, I'm going to call it A1. So we want to maximize A1. Can anyone, based on x and y, give us this area, the inside area? A formula for the inside area. What is the length? How do I write the length? Knowing that this is x and this is 1 and this is 1, how much is this piece? Anyone?
I think someone said x minus 1.
But I didn't hear, sorry, my apologies. But it cannot be x minus 1. Gia, you said something, but I couldn't hear you. I don't think I'm deaf. I don't think I'm deaf, but I think I did. You were very, very soft-spoken.
Minus 2 times y minus 3.
Very good. Awesome. That's exactly it. So this piece is x minus 2 inches. And this piece is indeed y minus 3 inches. Very good. Awesome. So this is one I need to maximize. Find the maximum of this. will solve the problem. So I will distribute, and I have xy minus 3x minus 2y and plus 6. Okay. Remember, I cannot, in this class anyway, I cannot maximize or minimize a function with two variables. I can't. We don't know how. We have to use partial derivatives, and we don't know what that means yet. So somehow I have to get rid of one of the variables. One thing I know for sure, that I can replace this by what? Immediately.
180.
That's it. X can stay, but now I have to do something about this. And this will help. Can anyone tell us what to write, or what could y be replaced by, knowing that?
180 over x.
Brilliant. Thank you very much. So then I have a1, which is indeed finally a function of x and x only. 180 minus 3x minus 2 multiplied by 180 over x plus 6. Yay! I'm happy. Why? I have a function of x and the rest is a piece of cake. Can differentiate, find critical numbers, find the maximum. Done. So let's continue. I'm on page 11. So then a1 is 186 minus 3x and minus 360 over x. And this I know how to differentiate. So a1 prime, negative 3, plus 360 over x squared. Remember, negative 1 over x prime is 1 over x squared. We wrote that on the side a few times. Please remember, this is very useful, especially for the next chapter, last chapter of this course. Okay, so when I set this equal to 0, I will get, I have to find the least common denominator, negative 3x squared plus 360 over x squared equals 0. And I know, I asked you many times, you always gave me the correct answer. A fraction is 0 when the top is 0. So negative 3x squared plus 360 equals 0. I divide, I can move. So that's x squared it's 360 over 3. So x squared is 120. I will take the square root, of course. I will not get plus or minus. There is no discussion there, right? Of, what do I have here? 4. So 120 is 2 squared times 3 times 2 times 5, right? So I can only take 2 out, right? Yes, so it's 2 the square root of 30. But no, because we're talking about the distance. I have to write plus or minus when I take the square root, but we are talking about the distance, and this is inches. So I can't consider plus or minus. I have to consider just plus. Now, I will immediately go and get y, because I got x. I want to get y as 180 over 2 the square root of 30. And I simplify. And I rationalize. So y equals 90 times the square root of 30 divided by 30. So it turns out that y equals 3 the square root of 30 inches. So the length has to be 2 the square root of 30. We can approximate it, and we should. And the height will be 3 the square root of 30, and we should approximate it. And this is in inches. However, the problem is not done. I have to show that indeed 2 the square root of 30, let's approximate it, 2 the square root of 30, I get 10 point, about approximately 11, and 3 the square root of 30, 16.4. So I have to show and convince you that this gives a maximum. a1 prime of x. Okay, so where's my function? My function is right here. So this is always positive. On the left will be positive, on the right is negative. So this is definitely a maximum. And if they want us to find the maximum area, A1, I have, where's my A1? A1 is here. So I have to plug in. So I have 186 minus 3 times 11, so 33, and minus 360 over 11. And that is the maximum area, approximate, because I rounded up the 11. So 186 minus 33 minus 360 divided by 11, and I got approximately 120 squared inches, of course. So these are really the culmination of what we've been doing the entire semester.